So I've already done a video where I showed the relative distances of the planets from the sun, right? I was outside and I had the sun, I drew it right in chalk, had the basketball way out there. So I showed the relative distances of the planets from the sun. Now we're going to talk about the relative sizes of the planets to each other, and we're just going to talk about a couple of different aspects about each planet. And this is a really good opportunity for test questions. This is important, right? We're talking about our home, our solar system, our planets. So let me get this in there. Okay, so that's good. So remember, for the test, you have to know the planets in order from the sun. So this is the sun over here. That's the sun. So notice how big the sun is compared to the planets. It's huge, absolutely huge. Let me go down a bit. I think that's about the best I'm going to do. And you have to know the planets in order, right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, okay? So remember, the average distance of Earth to the sun is 1 astronomical unit, right? This is not the scale, right? You have to look at my other video to get the scale for distances. But this is showing the relative sizes. So you can see how big the sun, right? We're not going to show the whole sun. You can see how big the sun is compared to the other planets. The sun contains 99.9 something percent of all the mass in the solar system. Then you have four planets, and then there's some debris, right? Some small rocky planets and asteroids and rocks and Oort cloud and things like that. So let's talk about each planet. Mercury. Mercury is the smallest planet. It's the closest planet to the sun. Very dense. And by dense, I mean, so if we call water 1, if water has a density of 1, and it does, right? If you have one gram of water, is in 1 cubic centimeter. So a cubic centimeter, right? A centimeter. Picture a little cube, 1 centimeter each side, and then it was filled with water. That'll have a density of 1. So if you had an average chunk of mercury, well, it's just a rock. It's going to sink. In fact, an average chunk of all these planets would sink in water except for Saturn. Saturn's very fluffy. So Mercury is very close to the sun. It's very hot, as you can imagine, right? It's really hot there just because it's so close, right? So it's the smallest planet, and it's very hot. Next you have Venus, right? Venus is much farther away from the sun than Mercury is, but nowhere on Mercury is it as hot as on Venus. Even though Venus is much farther away, it's way hotter than Mercury because Venus has an atmosphere, very thick atmosphere. In fact, its atmosphere is mostly carbon dioxide. It absorbs the sun's energy and holds it in, right? You may have heard about the greenhouse effect, right? We talk about that on Earth, climate. We worry about a man-made climate change. If we put too much carbon dioxide into our atmosphere, it will heat up our atmosphere. Well, it's true. That's what happened with Venus. Venus has, its atmosphere is mostly carbon dioxide, and it's just incredibly hot. At the surface, lead will melt. If you have lead, it'll melt on this. It's like 900 degrees on the surface of Venus, so it's very hot. Very thick atmosphere. The weight of the atmosphere would crush you. Or if you ever dove down in a swimming pool, you can feel the pressure on your ears just from that little bit of water. Venus has an incredible pressure, right? It would crush you. So, okay, so Mercury, Venus, Earth, we don't care about Earth, right? Then Mars. So Mars is the next planet. We end up sending a lot more spacecraft to Mars, even though Venus is closer, because Mars is a lot more hospitable. It's cold, but the warmest places on Mars are still warmer than the coldest places on Earth. So at Mars' equator, it's like whatever, minus 40 degrees or something like that, Fahrenheit and centigrade. But we have those temperatures on Earth. So Mars is a lot easier to send spacecraft to. Mars has an atmosphere, but it's a very thin atmosphere. Its atmosphere is largely carbon dioxide as well, but the atmosphere is so incredibly thin that it just doesn't have the effect. Also, Mars is small, and so its gravity is not strong enough to hang on to its atmosphere, so it's lost quite a bit of its atmosphere. Okay, Jupiter is the biggest planet. Jupiter is huge, right? Really, really big. You can see it has all sorts of storms at its surface. These are bands where these clouds, the gases are circulating in different directions. So Venus is the biggest planet. It's probably, you could probably classify it as mostly a liquid planet. We're looking at the outer atmosphere, but as you went in, it would be largely liquid. But then it's so big that the gravity is quite strong. It eventually would get solid towards the center, but there's a lot of weird things that you have, like a metallic hydrogen, which is something that we don't have anywhere naturally on Earth. I think they can do it in laboratories, but the gravity is so intense because it's so big. Yeah, that you get a lot of effects you just don't have on Earth because of the strong gravity. Then Saturn, of course, is the prettiest. If you ever get the opportunity to see it in a telescope, it's amazing. It looks like it's almost as big as Jupiter, but it doesn't have anywhere near the mass. It just doesn't have as much stuff. It's quite fluffy. Like I said, if you had an average chunk of Saturn and you were to put it in water, it would float, right? So Saturn is very fluffy. Of course, it has the rings that go around, right? They go around counterclockwise as well. And notice, and the inner rings, of course, go faster than the outer ring, because if you're closer to the planet, you move quicker. Remember Kepler's law. Okay? And then you have Uranus. These are Uranus and Neptune. Very pretty planets, kind of bluish. What's interesting about Uranus is that it is tilted on its side about 90 degrees. So the theory is that early in its formation it was hit by a big object of some sort, big meteor or another planet, knocked it on its side. So it actually spins. It spins this way. So its poles are like sideways this way. So very interesting. This is showing Saturn tilted, but it's not quite tilted so much. And then what I forgot to say about Venus actually spins backwards. It spins backwards very slowly. So that the theory is maybe it was like knocked completely over or hit in such a way that it spun it the other way. More likely it was just knocked over. And then the last planet, right? So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. What I want you to know about Neptune is very similar in characteristics to Uranus, but Neptune was found mathematically hundreds of years ago. I'm always impressed when people do things a long time ago. Hundreds of years ago, they were studying Uranus. They go, you know what? Its orbit isn't right. Something is off. There must be another planet that's tugging on it with its gravity. And sure enough, they went and they looked, and there it was, pretty much in a spot that the mathematician had said it would be. That was huge. Nowadays, discoveries are made mathematically all the time, right? The universe is very mathematical. This is common these days. We model things mathematically. We're like, well, you know, we make predictions and we say, okay, yeah, there it is, right? We do that all the time. Back when that happened, that was huge, that you were able to do math, and then the physical world worked like the math. That was like, holy cow, right? That was a huge thing. So what I want you to know for the test is that Neptune, it was first predicted mathematically, and then it was discovered. So Mercury, Venus, Earth, Mars, Jupiter. Thank you, Norton. Okay. The Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, right? So I want you to know that. I want you to know that about our solar system, our planets. Oh, I forgot one thing. In between Mars and Jupiter is the asteroid belt. So there's actually a whole bunch of asteroids here, right? Asteroids are small, rocky little bodies. It's almost like there was a planet here that didn't form. It couldn't form, and the theory being very strong evidence that because Jupiter's gravity is so strong, it interfered. So when everything was coalescing, this planet was not able to form, and it just stayed an asteroid belt. So there's just a whole bunch of asteroids in between Mars and Jupiter. Very interesting, the asteroid belt.